Welcome to part 1 of Competency 6 quiz. In this video, we will work with properties of functions. Number 1, solve x squared minus 3x plus 5 equals 0 for the value of x. Well, the first thing that we need to look at is the discriminant. If we evaluate the discriminant first, then we might be able to eliminate at least two of our options, okay? Well, let's take a look here. We'll just pop that in the calculator, all right? So I see B is -3, so parentheses -3. And remember that I do that to secure my order of operations, okay? So I don't have those errors. So we need to square that. Minus the 4, and 1 is our A, and C is 5, okay? And yes, I use the parentheses and put it in exactly like we would write it for the equation itself. Okay, let's push enter. That is actually a -11. What does this tell me? It tells me that my discriminant is actually -11, which is equal to I with 11 under the square root. Remember, our discriminant is under the square root. Okay. All right. So what do? Well, A is not a complex situation. There is no I. So get rid of A, and the same for C. Now we need to take a look at the actual equation. Okay, well, B is -3. Now, let's look at what we have. I mean, I can see right away what's going on here. I have negative, remember, it's negative b plus or minus, and then the discriminant. So b is negative. So really, my new numerator will look like this, correct? But what happens to this b? That becomes a +3. Well, that eliminates D, and I'm going to go ahead and write the whole thing out. If you know the properties, you can quickly eliminate a lot of options very quickly. And generally, sometimes on practice tests, especially, they're testing to see if you know enough. And now remember, some of your programs, you guys may be studying because you're in an entrance. You got to deal with entering into a math program. Well, these are just basics that you have to know. Also, teaching your students. Okay. All right. So let's look at 2. We'll look at 3. Okay. Find the roots of x squared plus 2x minus 6. Well, what I want to do is, again, look at the discriminant and see if we can eliminate some of these. And is this situation complex or not? Okay, well, let's take a look here. All right, let's do the same thing. Let's deal with the discriminant. Well, b is positive. That's a positive too. So 2 squared, we don't need the parentheses. You can use them. The reason I use the parentheses is because it was a negative prior, okay? So minus the 4. Again, we have 1, but we do have a -6. So that's a negative situation. Well, that is not a negative discriminant. It's a positive discriminant. So let me push my toggle. Okay, never mind. All right, so what I'm going to do is I'm going to push second. I didn't have it under the radical. So now I put it under the radical, push enter. Automatically I have that 2 square roots of 7. And I know that it is not complex because we had a positive 28, okay? And if it had been a negative under the radical, if I had tried to put a negative under this radical, this particular calculator would have given me an error. Okay, so what do I know? I know that A is complex, but our equation is not complex. so I can get rid of A and C. Now, let's take a look. My calculator gives the discriminant as equaling 2 square roots of 7. So quickly do a little setup. Okay, I know I have 2 because 2 times 1. Okay, let's do it correctly there all the way. That's going to be 2. All right, so I'm going to go ahead and put 2 here. And then B is just going to be -2. And then positive negative 2 square roots of 7. Okay, well, look at what really happens. I'm going to get rid of where I did this. Let's pull in another color here and start doing some cancellation. Well, I'm going to get rid of this too, and I'm going to get rid of that too, and I'm going to get rid of that too. Interesting. What really is left? -1, positive, negative, square root of 7. I kind of was like jumping ahead of myself, and that's why I erased what I had because I didn't need to do that. I know what the value is now. It's B, and mark through that. Now, if you get stuck on one of these, you could try some decimal approximations, put this original uh, equation into your table function and deal with that. Well, we didn't need to do that because we know the formula and it got there quickly. So we're good. However, we need to check number 3, which of the following values of x satisfies. Now this we pop directly into our calculator. And what we are looking for is when we put it in the calculator, any x value that ends up being for the total, which be our right hand side, it has to be greater than 0. It cannot be equal to 0. It cannot be less than 0. It must be greater. Okay, that's because that's our condition. Okay, so what do I mean? Second, okay, push your table, clear all that out. 2x squared, all right, plus 5x, all right, minus 3. Push enter. I'm going to start at 0. Actually, just go 0, 1. Start at 0. Steps 1. But notice how we have ask highlighted. In this situation, that's the fastest way to get there. Absolutely the best. So push enter to OK. Now, delete out this prior because that's from another uh, problem we had. This is what you do. You just go down your ABCD list and pick the one that is definitely greater than 0. Okay? Watch what I do. All right. -3 minus 3. That's equal to 0. Not going to work. It says your total answer over here for your y must be greater. Okay, so then 1 divided by 3. Remember, it won't take fractions in here. So just divide it out. Nope, that's less than 0. That's not going to work. And I bet a half won't work either, but let's try it. 1 divided by 2? No, equal to 0. So it has to be 2. Pop in 2, enter, yes. That is greater than 0. Very simplistic, but a great question to see if you understand these properties and what that condition actually means, okay? All right, let's go on to number 4. Okay, number 4. If the equation 2x squared minus 4x plus c equals 0 has 2 complex roots, what are the restrictions of c? Okay, so we will have to use the discriminant for this because it says complex roots. So what does this mean? If roots are complex, the discriminant will be less than 0. So what do I mean? Well, we have -4 here. So -4, that's our b, squared, minus 4. And A is 2, and then we have our C, and that must be less than 0. Now, I don't right away, you know, solve everything here, what I do is say subtract negative 4, 2 from both sides. Okay. All right. For accuracy. All right. So what do I know is going on here? I know that that's going to equal 0. Okay. So now I know 2 times 4 is 8. Negative 8c is less than negative what? Well, now go ahead and just pop that in the calculator. Just in case it's a large number, I'm going to say negative parentheses, negative 4 parentheses, square that guy. Of course, it's negative 16. Okay. I know you saw that coming, but when you're taking a test, this calculator will not take that long to push the buttons. Okay. Now, what do? Well, you need to know the properties. Okay. When I divide both sides by negative 8, this guy right here, I can no longer use him as is. I must go down here. I need to flip him around. And now I know I have C is greater than. Okay, and if you can't see, right, we know what this is. That's just 1. But over here on the other side, yeah, I'm sure you know what the answer is. I get it. But just in case the numbers are large and you are very tired, it's getting towards the end of that test. Create the fraction on your calculator, push enter. We know what it is. Okay. And you know what? Honestly, I wouldn't even take the time to write down the final value that I've done here. I'm doing it just to teach. What I would have done already is said the minute I saw that I was going to divide by negative 8, I would have come over here and gotten rid of A, and I would have gotten rid of C. And now I know that B has to be the value because my calculator gives me 2. Okay. As you move along, only write down what you need to. I write down more sometimes, to be honest, than I ever would have on a test. Okay. All right. So let's look at number 5. Which description of the roots of an equation describes a quadratic equation that has a vertex on the x-axis? First, we need to be logical. Okay. I'm just going to quickly draw the grid, like a little coordinate. There's my origin. Okay. The truth is, it says the vertex. The minute it says vertex is on the x-axis, this means I have one dot on the x-axis. And either it's going to open up. Well, actually, it has to open up. Not necessarily. Or down. But we know that will be right here. This implies one real root. Yeah, so it could open down. Whatever, doesn't matter. This is all we have. Okay. And that means you have one real root and no complex generally. Okay. We're not going to have complex. All right. Because it's a quadratic, it's not cubic. Right. If it had been cubic, that would be different. But because of this detail that they gave us, that's what we have to go with. So let's look at A. The equation has one real root and no complex. Okay, I agree with that. Now let's check the others. Okay, the equation has one real root and one complex root. No, complex roots have to be in pairs. That's not going to wash. No. Uh-uh. The minute you see any option where it says something has one complex root, scratch it out. Something's wrong. Something is invalid. Go back and look again. In our situation, we know to mark it out. But if it's like shaky for you, go back and read the problem. Okay. All right. Now, see, the equation has no real roots. What? It's touching the x-axis. It has to have a real root. So, nah, get rid of that. All right, let's see C. The equation has two real, no. That's not going to work. Because if that thing had two real roots, it would have looked like this going through. And we would have had something here and here. And that's not what we have. So that's not valid. None of that is valid. Okay, so that's gone. So what do? We mark that out and we stay with A. A has been verified. All right. Okay. And let's go up to number 6. Okay, there we go. Which of the following points is the vertex of the graph of y equals 2x minus 8x plus 1 in the y plane? Oh, this is a situation where we pop in the calculator and we just look at it. We like literally pop in using ask each of our X values there. Oh, yeah, absolutely. That's what we're going to do. See these guys right here? We'll test them out. Okay, so let's do this. Table, go ahead and just clear it and type in fresh. X, okay, 2x squared, okay, minus 8x plus the 1. All right, push enter and leave everything exactly the way it is. I need the 0 and the 1 and the ask and the okay and enter. But now we need to delete it all out because we're going to be testing all of these. Okay. So first we need to test 0, 0, enter. Um, well, yeah, that's okay, but is it the vertex? Okay. Let's see. 1, enter. Oh, that also shows up. 2, enter. Okay. So that isn't going to work. Mm. So what do we really need to do? They're trying to trick us. They're saying, well, if you use ask, all of these that are part of that equation. Ah, well, that was a nice try. So what do? Quickly bounce back over, go to auto just by pushing enter. Now push enter again and go to OK. Now we have something to look at. Well, let's see what happens here. Oh, if we had typed in 3, we would have seen that pattern, okay, where 2, the coordinate 2, -7 is less. So that would make sense, and that would tell me that 2, option C with 2, -7 was actually the option that we needed. Okay, and 3 obviously isn't because it's shaped like this, and 1 and 3 would have been here, and down here our vertex is here. Okay, well, that has been verified. So let's try number 7. Number 7, which of the following represents a graph of x squared minus 6x plus 9 equals 0? Okay, well, what do? We pop it in the calculator, in the table, and look for the vertex. If we can't verify a vertex, then it's not the option that we want. Okay, for example, here and here and here, that looks like about 1.5, and here. Okay. So that's what we need to look for. Let's put it in the calculator. Okay, table, and clear it out. X squared minus 6x, okay, plus 9. All right, so push enter and go ahead and go with 0. Actually, yeah, because we're going to have to go arrow up and down, I think. So yeah, 0, 1. All right, so let's leave it like that and just keep pushing enter. Okay. Well, I have, if you want to go with 1, none of them are 1. How about 2? You would need 2, 1. Ugh, okay, well, that obviously isn't going to be a vertex. Let's try 3. Okay, let's go down. 3, 3, 0. Ah, that works. Remember, uh, we're testing them all. So this one is 3, 0. That works for me. However, then 2, 1, that means A doesn't work. And let's go ahead and try -3. Let's just go look at it. -3, nope, that's not at 0, so B won't work. And we can go ahead and eliminate C. Okay, that's a complex situation. If you want to, let's see, we can look at 1.5. How do you do that? Clear, go back to steps, okay, and say, you can do it two ways. You can either go to steps or go to ask. Okay, it doesn't matter. If you want to do steps, you do zero point 0.5, enter, and keep entering. And then you would actually have to go and see where it says, oh, no, one more right there. You can see that that obviously would not be it. Okay, so it is verified that we have D is the correct graph. All right, so let's look at A. 8. All right, let's see here. All right, number 8 says the number of gallons of paint you need to paint your kitchen varies directly. That's important. Directly with the area of the kitchen. 1 gallon of paint covers 100 square feet. How many square feet would 8.5 gallons of paint cover? Okay, a lot of good things being said here. All right, if you did the other videos with me for the indirect and inverse, which is indirect also, two ways they call that, inverse or indirect. Either way, if you did those, you know what we're looking for. So I want gallons to area, and I will set up not quite a proportion. Let's call this a comparison, okay? So if I have 1 gallon, okay, now I know 1 gallon here is 100 square feet. Well, where do I put that? Well, we're not saying that this is a traditional proportion, the way we teach the students. When it says direct, that means straight across, okay? So that's where we put the 100, okay? All right. Now, they're saying gallons. Remember, I have gallons to area, so I need to put the 1.5 here, and then that's where the X goes. So now you see exactly what to do. We see that X equals 100 times 8.5, which you probably already saw. We can put that in the calculator, and I'm sure you see what that value is. Oh, it helps if you back out of your prior. Okay, 100 times 8.5, then enter. Of course, it's 850 feet. Okay. All right. Now, I'm sure that these other options are there to mislead you. Okay, if you set it up incorrectly. But when you see the word direct, you know that the what goes together goes straight across. So like 1 gallon gives you 100 as far as area, the square feet area. So then 8.5 goes straight across would give you that comparable value, okay, which is 850 feet. Okay, all right, this is actually the last question in this video. Again, oh my gosh, thank you so much, guys, for watching till the end. And congratulations to those of you who have sent me a notice that you've passed your test. Kudos to you. And thank you for sharing and liking and subscribing. Happy testing, everyone.